Good day, students. Welcome to the uh, New York State Regents exam release questions review session. I'm going to be going over questions 1 to 10 of the release exam for Algebra 2 slash Trig. Um, and this exam was administered on January 2012. If you want to get access to this document, all you have to do, you can just go to Google and type in NYSE Regents exam, enter. The first search item you get is the Regent exam, and when you click on that, you see all the exams that have been released. The one I'm working on right now is the Algebra 2 Trig, so if you click on that, the January 2012, expand that, and then if you click on examination, you get the document that I'm working on. And the answer key and the scoring guide is also included. All right, so there you have it. Okay, all right, let's go ahead and get started going over questions 1 to 10. Let's take a look at number 1. Question 1 says that the year book staff has designed a survey to learn students' opinion on how the yearbook could be improved for the first year. If they want to distribute this survey to 100 students and obtain the most reliable data, they should survey. Now, if they want to get the most reliable data for the whole school, they want to try and increase their sample space as much as possible. So they don't want to have classifications like focus on just students of a certain behavior type or students that have certain schedules. They want to make sure that they hit as wide variety of students as possible. So let's look at these options and see which one has the widest range to reach students. All right, so first we have every student sent to the office. Is that inclusive of everyone? Does that give exposure to all students? Absolutely not. So let's say in this school, students sent to the office are students that have behavior problems or special circumstances. Students that do not fall into this category are not going to get surveyed, so that actually doesn't give you reliable data. How about every third student to enter the library? Now, not every student has a course that requires them to go to the library, or some students might go to libraries outside of school, but if you're focusing on only the students that go to the library, you're not being sufficiently inclusive. You need a bigger sample space in order to get more reliable data. Every third student to enter the gym. Now, does every student go to the gym for the basketball game? Absolutely not. Students might not even, there are many students that might not even care about basketball or whose schedules do not permit them to watch the game. So this one again is exclusive, is not sufficiently inclusive. Let's look at the fourth option. Every third student arriving at school in the morning. Now, does every student arrive at school? Yeah, if you're going to school, you have to arrive at school first, right? So this is a much more accurate approach to get a more reliable data. So every third student arriving at school is the best way to get the most reliable data. All right, let's move on to, so the answer to number 1 is option 4. So let's move on to question number 2. Question 2 says, what is the sum of the first of the first of the first 19 terms of the sequence? 3, 10, 17, 24, 31. So when it comes to sequences, there are 4 formulas to keep in mind: the geometric formulas and the arithmetic formulas. So let's look at this series that we have right here. Is it arithmetic or geometric? If you notice, if you keep adding, it's arithmetic. If you keep multiplying, it's geometric. If you notice, from 3 to 10, you can either multiply this by 10 over 3 or you add 7. Okay? If you multiply this by 10 over 3, if you multiply 3 by 10 over 3, you get 10. If you multiply 10 by 10 over 3, you get 100 over 3, but that's not this. So that clearly shows it's not geometric. So what do you do every time? Every time you add, right? So you have 3, 10, 17. What's going on here? You notice that every time you add 7. Yes, you add 7 every single time. Okay? So that clearly shows that this is an arithmetic series. So what we're going to be doing here is we're going to be using the arithmetic series formulas. All right. So there are two of them. What are the arithmetic series formulas? One of them is the sum of infinites of a finite arithmetic series is included in your reference sheet, but the nth term formula is not included. All right. So these are the two formulas you need to know. The sum formula. The sum formula is Sn equals n over 2 times a1 plus an. This one is included in your reference sheet, but the nth term formula an is not included, which is a1 plus n minus 1 times the common difference. All right, so these are the two formulas that are required to do problems involving arithmetic series. When you're working with geometric series, you have a different set of formulas to work with. All right, so this is arithmetic. Let's use this. So we're looking for the sum, so we're going to be using the sum formula. Okay, so for the sum formula, let's list what we have. We know n. N is the number of terms. How many terms are we dealing with here? 19. A1 is the first term. What is the first term in this arithmetic sequence? 3. We also need the nth term. Since n is 19, we're going to be looking for the 19th term. What is the 19th term? Oh, I have no idea, so let's put question mark there. So how can we find the 19th term? We have to use this formula right here. Okay, we don't have enough information to use the Sn formula. Okay, because if I wanted to do S19, I'll need A19 also. So I'm missing AN. All right. So we need to find the 19th term, and then we'll be able to use this formula right here without a problem. So how do I find it? I'm going to use this formula first. So A19 is going to be A1, which is 3, plus N is 19, minus 1 times D. What on earth is D? What is the common difference? The common difference is what you add every time, or you can do A2 minus A1. All right, so 10 minus 3 is 7. So the common difference is 7. All right, so let's solve this to find what A19 is. So this is going to be 3 plus 19 minus 1 is 18. 18 times 7. And then you're going to have 3 plus 18 times 7 is 126. And I add this to get 129. All right, so A19 is 129. All right, now we have enough information to find the sum. All right, so let's erase this. And now we're going to use the sum formula, which is S19 is going to be n over 2 times A1 plus A19, okay? All right, let's do it. So n is 19 divided by 2. A1 is 3 plus A19 is 129. All right, so we're going to have 19 over 2. And then 3 plus 129 is 132. We can write this as a fraction and cross reduce. 2 goes into itself once. 2 goes into 132.66. And then when you multiply 19 times 66, your answer is going to be 1,254. Okay? So remember, in this exam, you're allowed to use calculators. So let me show you how you can use a calculator to do this, to do this problem. Okay, so remember, it's 1,254 as a result. So if I wanted to do 19 over 2 times 132 over 1, let me just do it over here. So 19 over 2, and in parentheses, you go 19 divided by 2 times 132, like that. And you have 1,254. All right, so remember, anytime you're entering a fraction using your graphing calculator, you have to group it in parentheses. Okay, so your answer for number 2 is option 3. All right, so there goes the answer right there. Okay, so let's move on to question number 3. It says, which expression when rounded to 3 decimal places is equal to negative 1.155? This is a test on the use of the graphing calculator. So let's see which of these gives you the desired result. So you have to remember your trig identities. On a standard graphing calculator, you have just sine, sine of x, cosine of x, and tan of x, right? But these are not all the trig functions that there are. There are 6 of them, right? We have cosecant of x, we have secant of x, and cotangent of x. Since these are not in the calculators, we have to improvise, right? We have to use the reciprocal identity. So if we're working with cosecant, what we're going to enter in the calculator is 1 over sine, since we don't have that. Some advanced calculators have this, but if you don't, just reciprocate sine and you'll be fine, all right? And then secant is 1 over cosine, and then cotangent is 1 over tan. All right, so in this case, we have secant 5 pi over 6. So how on earth, what do we enter in the calculator? For secant 5 pi over 6, we're just going to enter 1 over sine, 1 over cosine 5 pi over 6. Well, why do I do that? Because secant is 1 over cosine. You see that right there? Right. So secant is basically 1 over cosine. So that's what I'm going to be entering into my calculator, right? So when I enter that into my calculator, if I get this result, then that will be my answer, right? So remember, I'm going to enter secant 5 pi over 6 is 1 over cosine 5 pi over 6, and this is what I'm going to enter into my calculator, this piece right here, right? So watch how I do this carefully so that you can enter it accurately in your calculator too. So we're going to do, clean up, 1 divided by cosine 5 pi over 6. Now, one thing you have to be careful about is, since we're dealing with radians here in terms of pi, your mode has to be in radians also. If we're dealing with degrees, like option 2 and 4, then you have to switch it to degrees, all right? So since we're dealing with radians, we're going to do 1 over cosine 5 pi over 6. And your answer is negative 1.155, negative 1.1547. If you round this to 3 decimal places, your answer is automatically that. So answer to number 3 is option 1, because this is the same thing as that. All right. So answer to number 3 is option 1, like that. Okay. Now, moving along to question 4. It says if f of x is 4x minus 2x minus x squared and g of x is 1 over x squared, then f composed with g of 1/2 is equal to. Now, there are 2 different ways of approaching this. I'm going to show you the 2 methods, and whichever method you like, you can go ahead and use. All right. So the first method involves finding the composition of the 2 functions and then inputting it. All right. So I'm going to call this method 1. Method 1. You first of all find f composed with g of x, and then 2, plug in 1/2 for x. All right. So let's do that. So what is f composed with g of x? What on earth does this mean? Well, this simply means that you're going to take g is your input into the parent function f. So you're going to have f. You're going to take all the x's from f, and then you replace it with g of x. Okay, so you're going to substitute g into all the x's in f. All right, so this is g right here. We're going to take this, and we're going to input it into this x right here, and then we're going to input it into that x right there. All right, so what on earth does that look like? Let me erase what I just wrote. Let me erase this and then show you what it looks like. So first of all, I'm going to write down the parent function, which is f. So f of x is 4x minus x squared. So I'm going to plug in g. So in order to do that, I have to replace all my x's with parentheses. All right, so here I have parentheses, 4 parentheses. Let me make these parentheses stretch vertically since we have a rational expression to input here. So 4 like that minus parentheses here squared. All right, so the input function is g, so I'm going to put the g of x on the left. And then what's the value of g of x? 1 over x. Okay, so 1 over x here, and then 1 over x here. All right, let's simplify that. If I simplify it, I'm going to have 4 over x minus 1 over x. square, because 1 square is just 1, and then x squared is x squared. So this is f of g of x. All right. Okay. Now I'm done with the first part. Find g of f of x. Now what we're gonna simply do is we're gonna plug in 1/2 for x. All right. So second part, plug in 1/2 for x. So when I plug in 1/2 for x, it's gonna now become f of g of 1/2 equals 4 over 1/2 minus 1 over 1/2 squared. Alright? So what is 4 over 1/2? Well, I can just multiply 4 by the reciprocal of the denominator. Anytime you're dividing by a fraction, you multiply by the reciprocal. Okay, so I'll flip this to 2 over 1. 4 over 1 times 2 over 1 minus, and then I can, let me just expand this one first. 1/2 squared is going to be 1/4, right? It's 1 over 4. Okay? And then here I'm going to have 4 times 2 is 8 minus, what is 1 over 1/4? I can multiply 1 by the reciprocal of that, which is basically 1 times 4 over 1. And then you're going to have 8 minus 4, because 1 times 4 over 1 is just simply 4. So our final answer is going to be 4. Alright? So just remember, anytime you have a fraction in the denominator, just reciprocate it and multiply it by the numerator. Okay? So you just drop the top, change the division to a times, and then flip the bottom and times by the top and get your answer. So the answer to number 4 is 4. Okay? Alright, now let's do the same problem using another method, method 2, and then you can pick whichever one you like to do when you come across questions involving composition like this. Alright? So for method 2, what we're going to do, make it a little smaller. So for method 2, this is the procedure I'm going to use. Okay. Method 2. First of all, I'm going to plug in 1/2 into g of x, and then 2, plug in my result into f of x. Okay, so what's happening here is basically you have 1/2, and then you have the function g of x. This gets plugged into that one right here, so you're going to have g of 1/2, and then you have another function which is f of x. So this whole result that you have right here gets plugged into f, so you're going to have f of g of 1/2. So this is what I'm going to do right now, right? So the first part 1, I'm going to find g of 1/2. What on earth is g of 1/2? It just basically means you're plugging in 1/2 into g, okay? So g of x is 1 over x, as indicated here. So g of 1/2 is going to be what? 1 over, let me put it in blue so you can see, 1 over 1/2. Because that's basically what the input is, right? So let me color code it so you can see what I'm doing here. So the first part, we're plugging in 1/2 for x. Alright, so what does this become? Remember, you can multiply this by the reciprocal, multiply the numerator by the reciprocal of the denominator, which is times 2 over 1, and then your final answer is 2. Okay. Now I'm done with this part. Now the next part is this result, I'm going to plug it into f. So next thing we're going to do is we're going to find f of 2. Okay? So f of x is 4x minus x squared. So what is f of 2 going to be? Just plug in 2 for all the x's, right? So 4 times 2 minus 2 squared. It's going to become 8 minus 4. But 4 times 2 is 8, and then 2 squared is 2, which equals 4. And the answer is 4. Alright? So that shows the answer is 4. So you can use method 1 or 2. Method 2 looks a little bit shorter and less complicated, but left to you to decide. Alright? So there you have it. Okay. Now let's move along to question number 5. Alright, so for question number 5, it says the population of rabbits doubles every 60 days according to the formula P equals 10 times 2 to the t over 60, where P is the population of rabbits on day T. What is the value of T when the population is 320? So what we're going to do here is we're just going to take, P. P is 320, right? We're going to plug that into this equation right here. Plug that, because population is P, we're going to plug that into P right there, and then we're going to look for T, because that's what we're looking for, all right? So to do this, I'm just going to rewrite the whole formula, and then we're going to plug in what we know and find what we need, okay? So the formula for population growth is P equals 10 times 2 to the T over 60. Okay, now I know our population is 320, so I'm going to have 320 equals 10 times 2 to the T over 60. Alright, so the goal here is to solve for T. How do we do that? I need to eliminate this power first, and then this coefficient first, and then we'll go from there, okay? So since this has been multiplied by this exponent right here, the opposite of multiplication is division, right? So just divide both sides by 10. And then I'm going to end up with 32 equals 2 to the T over 60. Now let's take a close look at this though. Can I express 32 as the power of 2? If I could, then whatever the powers are, they could be equal, right? So what is 32? If you think about it, 32 is a power of 2 because 2 to the 1 is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. Voila, this is what I need right here, okay? So I can re-express 32 as 2 to the fifth equals 2 to the T over 60, all right? And then if I can just take log base 2 of both sides, log base 2 of 2 to the fifth equals log base 2 of 2 to the T over 60. Since we have since these two numbers are the same, it's really convenient for us, right? Because this cancels out right here, this cancels out right here, and the exponents, as you might have guessed, are the same, are equal, so 5 equals T over 60. If I didn't have the same numbers here, I have to use natural logarithm, and it'd be slightly more complicated, and you have a decimal answer, right? So to solve this, let me write my T over 60 differently. I like to write it as a fraction, so T over 60. To solve this, all you just simply do is you can write this as a fraction and cross multiply, and then you have 300 equals T. Okay, so the population is 320. T is equal to 300 days. So our answer is 300 days. All right, let's move on to question number 6. Question 6 says, what is the product of x minus 4, x over 4 minus 1/3, and x plus 4 plus 1/3? There are two methods of doing this, the quick weight method and the long method, okay, and I'll show you both methods, all right? So for method one requires that you know the formula, that you need to know the fact that a plus b times a minus b is simply a squared minus b squared. Difference of squares, right? If you notice, this is a right here, this is a, x minus 4, see they're both identical, and this is b 1/3. And what do you have? You have a minus b and a plus b, but multiplication commutes, right? So I can switch them around. So I can use this idea to find a product. Okay, so using this whole idea, I can just say x over 4 plus 1/3 times x over 4 minus 1/3 equals a squared, which is x over 4 squared, minus b squared, which is 1/3 squared. If I expand that, I'm just going to end up with x squared over 16 minus 1 over 9. And that's my answer. Answer is 2. So this is method 1. It requires that you know this formula, okay? So method 2, we don't know we're just going to act as though we don't know the formula, okay? And we're just going to work it out. We're just going to distribute. We're going to find the product, all right? So method 2, you just expand, all right? Some people call it FOIL, whatever you like to call it. So we're just going to straight up just expand the whole thing. So we're going to do x over 4 plus 1/3 times x over 4 minus 1/3. You see we get the same answer, right? So all you just do is you just distribute. So I'm going to go this and this, and then I'm going to go that and that, all right? So let's do the first one. First, we're going to have x over 4 times x over 4. That's first. And then minus, because you have a minus here, x over 4 times 1/3. And then we're going to do the first outer, and then inner is positive 1/3 times x over 4. And then lastly, minus 1/3 times 1/3. Okay? Alright, if we multiply this out, we're going to have x squared over 16 minus x over 12 plus x over 12 minus 1 over 9. Okay? So whenever you multiply fractions, you just multiply across top to top, bottom times bottom. If you look at these right here, you notice that these two are opposite, so they cancel out. And your final answer is going to be x squared over 16 minus 1 over 9. Well, that's what we had before, so our answer is 2. Okay? Alright. Now let's move along to question number 7. It says, which of the following is a graph of y equals cotangent x? Now this one, if you have your graphs memorized, you automatically know that option 3 is the answer. This is a tan, right? And then you have it's undefined whenever tan is 0, so you have that undefined nature happening there whenever the tan graph hits the x-axis. So let's assume that we do not know, we don't have the graph memorized, but hey, we're free to use our scientific calculators for this examination, right? So let me show you how you can use a calculator to basically figure out what the graph looks like. All right, so we know that in a calculator, let me show you my calculator. I don't have cotangent anywhere here, but I have tan though. So how can I connect tan and cotangent? Remember the identity that you have to remember the identity that cotangent x is basically 1 over tan x. So if I want to draw the graph of y equals cotangent x, I can just put in 1 over tan x in my calculator, and whichever one matches this, that would be my answer. Alright, so let's go ahead and do that. I'll bring up my calculator. I'm going to be entering, since I don't have cotangent, my calculator doesn't have cotangent, I'm going to enter 1 divided by tan x. This is exactly what cotangent is. Alright, and then we graph it. And then let's wait and see. Let's match. Which one looks more like this? It's either 3 or 2, right? But you look at 3, you see how from the y-axis it goes down like this? So this is the answer. So your option for number 7 is 3. Okay? So remember, even though you don't have all 6 trig functions in your calculator, you can use your reciprocal identities to find out what they are, right? So for sine, for example, sine can help you find cosecant. Cosine can help you find secant just by reciprocating, and then tan can help you find cotangent. Alright, so remember, even though you don't see them, you can actually use them. Alright? Okay, moving along. Alright, so for option 8, it says which expression always equals 1? So for this one, if you have your trig identities memorized, you remember that sine square x plus cosine square x equals 1, right? And since addition commutes, you can rewrite this as cosine square x plus sine square x equals 1. Alright, and then that, which of these equals that? Option 2. So just by memorizing your Pythagorean identities, you don't need to do much work to figure out what this is. Alright? Now, what if I didn't memorize my Pythagorean identity? Well, it turns out that there's a way that we can use our calculators to actually find out what this is. So what I'll do in my calculator, I'm going to graph y equals 1 for my first input function, and then my second input function, I'm going to enter cosine x squared plus sine x squared. This is how I enter it in the calculator. And I will see if I get 1. Alright? So I can, if I want, I can enter all these functions, but only one of them is going to match this perfectly. Alright, so I'm going to enter these two functions, and you're going to see that they will basically overlap each other, which shows that they're equal. If this doesn't overlap that, then that means that they're not equal. Alright, so what on earth am I talking about? Let's see. Let's start first. So I'm comparing all these functions to 1. I told you that the answer is option 2. So let's see how correct I am. So 1, enter, graph. You see that right there? That's y equals 1. Now I'm going to enter another graph. I'm going to enter parentheses cosine x squared plus parentheses sine x squared. If they overlap, then that means that I'm right. Okay, so graph. Uh-oh. Where is it? Where is the graph? Guess what? They overlap each other perfectly. That's why you don't see it. Okay? So that means our answer is correct. Well, if you don't believe me, I'm going to take this off right now. Okay? I'm going to take this off, and then I'm just going to graph the second one. So let's graph it again. And you're going to see. You see that right there? This is exactly the graph y equals 1. Okay, so what if I wanted to compare, what if I didn't know 2 was the answer? What if I wanted to try 1 first? So I have cosine square x minus, okay? Let's compare them and see if we get the same graph. Alright, graph them. How's the first one? Uh-oh, see the second one? 2 entirely different graphs. Since the graphs are different, that means they're not equal, alright? So whenever I have matching graphs, then that means that they're equal. So you can test these other 2 just to see that they are not actually 1. So our answer for number 8 is option 2. Okay? Alright. Now let's move on to question number 9. Question 9. Close this. Oh, wait a minute. I made it for number 10. Yes, I did. Okay, so question 9, it says, what are the sum and product of the roots of the equation 6x squared minus 4x minus 12? Alright, so for this one, I'm going to try factoring by grouping first to see if it's factorable. If not, then I have to resort to something else. So for this one, I have 6x squared minus 4x minus 12 equals 0. So I'm going to use a method called the x game, or the AC method, and see if I can factor this. Okay, so, oh, wait a minute. Note though that all the 3 terms are divisible by 3, right? So I can reduce this divisible by 2. So I can simplify this equation by dividing everything by 2. So divide this by 2, by 2, by 2, by 2. Okay? And then that's going to give me 3x squared minus 2x minus 6 equals 0. This is a much simpler equation to work with. Alright, so now AC goes on top using the AC method, and then B goes on the bottom. So A times C, and then B goes here. This is A, and this is C, and this is B. So AC is 3 times negative 6, which is negative 18, and then C is negative 2. So are there any combinations, any 2 numbers that multiply to give you 18 that add or subtract to give me negative 2? Well, let's see. For 18, I have 9 times 2. 18 times 1. What else? 6 times 3. This gives me this gives me 7 or 11. This gives me 17 or 19. This gives me 3 or 9. So none of them work. So this is a prime uh, quadratic trinomial right here. So I can factor it by grouping, okay? So does that mean that there are no roots? Absolutely not. Let's find the roots using the method that always works, which is the quadratic formula, alright? So I know that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright? So in this problem, a is 3. You gotta be careful with the signs here. B is negative 2, and c is negative 6. So I'm going to plug in these arguments into the quadratic formula, and that should tell me what the two roots are, and then I'll find the sum and the product. Okay? So I'm going to have, let's see, minus negative 2. Now, anytime you're making a substitution, please use parentheses so you don't mess the signs up, alright? Plus or minus the square root out. Negative 2 squared, that's b squared minus 4 times a is 3, c is negative 6. All over 2a, which is 2 times negative 2. Okay? 2, sorry, 2 times 3. Okay, stuff up. Alright, let's be careful here. So this is b, b, a, c, b. Alright. Moving along, we're going to have positive 2 plus or minus the square root of negative 2 squared is 4. 4 times 3 is 12. 12 times 2 is, 4 times 3 is 12. 12 times, 12 times 6 is 72, right? 12 times 6 is 72. So minus 72, which is plus 72. And then that whole thing divided by all over 6. Okay? So there you have it. Alright. Now, this can be simplified further into 2 plus or minus the square root of 78 over 6. Alright? Now, this can be broken down into 2 over 6 plus or minus root 78 over 6. Root 78 over 6. Okay? Which is 1/3 plus or minus root 78 over 6. Wait a minute, can we reduce root 78 though? Let's see if we can reduce that, okay? Root 78, since it's even, I can take out 2. If I take out 2, I have 2 goes into 7 3 times, remainder 1. So 2 goes here, 3, 39. And then, okay, hold on, I made a mistake somewhere here. Sorry about this. 72 plus 4 is not 78. 72 plus 4 is 76. I knew something was wrong. 76. Okay, so that's what I'm going to use. Alright, so 4 plus 72 is 76. 76. Alright, so if I take out 2 from 76, I'm going to have 38. And then if I take out 2 from 38, I'm going to have 19. And since 19 is prime, I'll leave it alone. Okay, so these two 2's repeat, so they will break out as 2. So this becomes 2 root 19, alright? So our result can be broken down further into 1 over 3 plus or minus 2 root 19 over 6. Okay? So 2 goes into 6, right? So 2 goes into itself once, and then 2 goes into 6 3 times. So our roots, our answer is going to be 1 over 3 plus or minus root 19 over 3. Alright, so our roots are, squiggly bracket, 1/3 minus root 19 over 3, and 1/3 plus root 19 over 3. Okay? Alright, the question says what is the sum and the product, right? So, if I just find the sum, well, let's see. Let's find the sum first. So if I want to find the sum all I do is I just add these two, right? So 1 over 3 minus root 19 over 3. I'm going to add it plus 1 over 3 minus root 19 plus root 19 over 3. So just add these two. 1/3 plus 1/3 is 2/3. And then root 19 over 3 plus root 19, since they're opposites, they just cancel out to 0. Alright? So 2/3 plus 0 is simply 2 over 3. Alright, so our answer, let's see. The sum is 2/3. Oh, how convenient. 2 is the only one with a sum of 2/3, so our answer is 2 over 3. Alright? So there you have it. Let's act as though we weren't paying attention. What if we wanted to find the product? What is the product of these two? Okay? The product of these two, we're going to do 1 over 3 minus root 19 over 3 times 1 over 3 plus root 19 over 3. Remember the trick I just showed you in the other problem? This is like a minus b times a plus b. What is it when you multiply a minus b and a plus b? This is a factored form of the difference of squares, right? It's simply a squared minus b squared, right? So if I apply that idea here, this, if I follow this out, it's simply going to be 1/3 square minus root 19 over 3 square. Alright? So that's simply going to become 1/3 square is you square the top and the bottom, 1 over 9. And then root 19 over 3, you square the top, you get 19 because if you do square root of 19 square and square is the opposite, they cancel out, right? So you get 19 on the top over 9 on the bottom. Okay? Using this formula right here. If this formula is too abstract for you, you can just distribute, the middle terms will cancel out, and you end up with the first square and the second square, which is just this, alright? So if I simplify this, I'm just going to have negative 18 over 9, which equals negative 2. So you can see that the sum is 2/3 and the product is negative 2. So that reaffirms our choice that the answer is 2. Alright? So there you have it. Alright, let's take a look at the last question. It says, given triangle ABC with A equals 9, B equals 10, and measure of angle B equals 70, what type of triangle can we draw? Now, there's some facts that we need to consider before we do a problem of this nature, okay? This is a law of sines problem, and it also involves the ambiguity involved in the law of sines, alright? So facts to consider. Alright, there's a lot of vocabulary here, and also rules to take into consideration. Alright, so these are some things you want to keep in mind. First of all, the sum of angles in a triangle has to be equal to 180. Okay, if it's more, then it's not good. It's not a triangle. Okay? Sum of angles must be 180. If it goes above it, then that's bad. Alright? Number 2, sine of an angle is positive in quadrant 1 and 2. Alright, so whenever you're taking the inverse sine, you can get two possible results. Alright, so remember, if you have your coordinate system like this, and you're taking the inverse sine of an angle to find what the angle is, your answer could either be in the first quadrant or the last quadrant. So this is your reference angle theta. Sine is positive here, and also with the reference angle theta, sine is also positive here. So sine is positive in quadrant 2, and sine is also positive in quadrant 1. So keep that in mind, alright? So anytime you take the inverse sine, you have to check these two quadrants to see which of the angles work. Alright, so let's keep that in mind. And then last but not the least thing to note is that number 3 is that an acute angle has no angle measuring 90 degrees or greater, and an obtuse, this one an acute triangle. Okay, sorry about that. And an obtuse triangle um, has one angle measuring greater than 90. Okay, greater than 90. These are just some facts to keep in mind when you're working on problems like this. All right, I'm just gonna leave these up here because we're gonna refer to them as we're solving this problem. All right, so the problem asks us, says, given this information right here, which of the following triangles can be drawn? Is it just an acute, an obtuse, both acute and obtuse, or neither? All right, so let's sketch a triangle first and put in our measures. It's always good to draw a triangle and label it as accurately as you can. Alright? You don't know if this triangle exists or not, so don't get stuck up on the appearance. Alright, so this is let me call this big B. Big B is always opposite of little b, right? So little b is 10. Measure of big B is 70 degrees. And then let's call this A. Now, all I need to do to determine whether this is an acute triangle or not is just simply find what the angles are, right? If all the angles are less than 90 degrees, then it's acute. If one of them is bigger than 90 degrees and they all add up to 180, it's obtuse. Okay, if I can create two cases, then we have acute and obtuse. So all I just need to do here is find angle B and angle C. All right, this is big C, there's little c right here. So since I have a side and an angle on the side opposite it, and I also have another side which is 9, I can simply use the law of sines in this case, all right, because we have ASS right here. So we have side to side, and then we have an angle. All right, so what on earth is the law of sines? Remember that on the reference sheet, the law of sines is provided for you, okay? So you can refer to that. So we deal with A and B. So what I'm going to do here is I want to find angle A. So what I'm going to do is I'm going to write down my law of sines and then basically use that to find it. So I'm going to go, since I'm finding angle, I want to find angle A. I can say A over sine A. This is the one I need. I know that, right? And then the other ratio, I need to know the little and the big, which is B, which is the B's, right? Since I know the B's, that's the one I need to put here. So little b over sine B is what I'll write, okay? So remember, all we're looking for is the three angles, so we can know what kind of triangle this is, all right? So let's plug in the things we know and then find what we need, all right? So little a is 9. Let me write my A like this so you don't get confused. Over sine A, I don't know what big A is, equals little b is 10 over sine B, which is 70 degrees. All right. Now to solve this, I can simply cross multiply. If I cross multiply, what do I have? Bottom to top, bottom to top. If I cross multiply, I'll have 9 sine 70 equals 10 sine A. All right. How do I get sine by itself divided by sine by 10? So you're going to have sine A equals 9 sine 70 over 10. Okay? And to finally isolate A, you do the opposite of sine, which is the inverse sine. So you take the inverse sine of both sides. So on the left side, you take the inverse sine of sine A equals, on the right side, you take the inverse sine of that whole expression you have right there. What did I do? Inverse sine, sorry. Inverse sine of 9 sine 70 over 10. Okay? So on the left side, the sine and the inverse sine cancels out. So you're left with A equals the inverse sine of 9 sine 70 over 10. Alright, this is the law of sines. Okay, so all we just do is plug this into a calculator and we'll be in business. Alright, so let's plug that in. Now, since we're working with degrees, we need to go to the mode and make sure that we are in the degree mode. Alright, so just press mode and then scroll down to the degree area the angle area, and then shift right to degrees, okay? So let's do this. So now, for that, I'm just going to go second function, sine, takes you to the inverse sine. You see it up here. It's yellow, so just press the yellow button and the sine, have inverse sine. Now I'm going to enter the numerator in parentheses, 9 sine 70. Close that. Close the angle, close the numerator divided by 10, and then close the inverse sine function. Bam. Your answer is 57.75. So let's use 57.75 as a measure of angle A. Alright, so angle A is 57.75 degrees. Alright, so we're done with the heavy lifting. Now let's go over here. So this angle here is 57.75. Alright, so this is one of the measures. So this is 70 and that's 57.75. What is this angle going to be? So angle C is going to be 180 minus 70 plus 57.75. Alright, so let's do that with the calculators. 180 minus 70 plus 57.75. It's not approximate, 52.25. So 52.25. So using our first result, what do we notice here? 52.25. All the angles are less than 90 degrees. So this is an acute triangle. So it could be an acute triangle, right? So this is a possible answer. But wait though. Remember I told you whenever you take an inverse sine, this angle could be either in quadrant 1 or it could also be in quadrant 2. Alright, so let's draw a coordinate system. The answer we just considered was a case where 57 degrees is in quadrant 1. And in that case, this is 57 degrees. In this case, for quadrant 1, theta, or A, is 57.75. But what if it is in quadrant 2? Because sine is positive in quadrant 2 also, right? So I'm going to extend it this way. But 57.75 in quadrant 2 is not the angle, it is the reference angle. So in this case, this right here is the 57.75. Alright? So for quadrant 2, for Q2, angle A is going to be this angle right here. From here all the way to there. So what on earth is that? Since the angle on a straight line is 180 degrees, to get its actual theta that we need, we're just going to go 180 degrees minus 57.75. Alright? So that's going to be the measure of the angle in value of A in quadrant 2. Alright? 180 minus 57.75. Alright, so in quadrant 2, angle A is going to be 180 minus 57.75. Plug that into our calculators. 180 minus 57.75, and you get 122.25. Alright, so A is going to be 122.25. Alright, A equals 122.25. Alright, so if we take a look at it, is it possible for that? Can that possibly work out? Is it possible? Can I have a triangle with those measures? So let's try it out and see if it's possible. So let me draw my triangle again. Remember angle B, this is angle B right here. Angle B was 70, right? Angle B was 70 degrees. And then angle A is 122.25. We're looking at quadrant 2, right? We know quadrant 1 gave us an acute triangle. If quadrant 2 can work, then we also know that obtuse is the case. What is angle C? Or is it possible? If you look at these two angles, if you add them up, 70 plus 122.25, what do you get? 192.25. You already went beyond 180 degrees. Remember I told you earlier that the sum of angles on a triangle has to be 180? Well, you add in b and a, and you already have an angle that's bigger than, a sum that's bigger than 180. Alright, so what does that tell you? That means obtuse is out of the question. Okay, so using this information that we have, the only triangle that works is an acute triangle right there. Okay, so it can be an obtuse, and it can be both, and it can be neither because it works perfectly fine with a cube. Alright, so there you have it. So thanks so much for watching this clip, and please subscribe to my videos so you can get updates to the subsequent parts, and do feel free to share with your friends, either on Facebook or Twitter or Google+. You can find more videos, math videos, on my site at math.serve.com. Okay, so thanks again for watching this, and have a wonderful day.